Unit 5 is more trigonometry. So we're calling this one analytic trigonometry, and we're also going to be solving trig equations. For the first section, to start us off, we're going to be talking about these things called fundamental trig identities. So our objectives for this are, first of all, recognize the trig identity. Then we're going to use trig identities to simplify trig expressions. And then we're going to use trig identities to rewrite trig expressions. So the biggest things we're going to be using here are substitution. So we're going to use substitution and simplification. So that's our main goals, the big things we're going to use. In order to solve, we're going to substitute and we're going to simplify. Here is a list of trig identities that we can use to substitute and also help us simplify some trig equations down. So the first section is about reciprocal identities. These are fairly familiar. Looking at sine and cosecant, they're reciprocals of each other. In other words, sine is equal to 1 over cosecant, and similarly, cosecant is equal to 1 over sine. Same thing with cosine and secant. Cosine is equal to 1 over secant, and secant is equal to 1 over sine. Tangent and cotangent are also reciprocals of each other. So tangent equals 1 over cotangent, and cotangent equals 1 over tangent. Quotient identities are, one should be fairly familiar. Tangent is equal to sine over cosine. And cotangent, you can kind of infer from the reciprocals. If cotangent and tangent are reciprocals of each other, well, then we should just take sine over cosine, take the reciprocal of that, giving us cotangent equals cosine over sine. So those are fairly familiar to us. Now, the Pythagorean identities are kind of new. So the first one, sine squared plus cosine squared equals 1. That's honestly probably going to be one of the most commonly used, most frequently used Pythagorean identities for our class. Now, thinking about good old Pythagoras and his identities, Pythagorean theorem has to do with the right triangle. Now, if you were to draw a right triangle from the unit circle, you'd have a radius of 1. In other words, the hypotenuse would be 1. The x, the horizontal, is your cosine. I guess I should probably use cosine of u here. And the vertical would be the sine. So using Pythagorean theorem, sine squared plus cosine squared equals 1 squared. In other words, sine squared plus cosine squared equals 1. The tangent and secant and cotangent and cosecant ones are related. I'm not going to dig too far into those right now, but 1 plus tangent squared equals secant squared, and also 1 plus cotangent squared equals cosecant squared. For this next section, this is called the cofunction identities. The sine of pi over 2 minus an angle is equal to the cosine of that angle. And similarly, the cosine of pi over 2 minus an angle is equal to the sine of that angle. The tangent of pi over 2 minus an angle is equal to the cotangent of that angle. And similarly, cotangent of pi over 2 minus an angle is equal to the tangent of that angle. Finally, these are all kind of related. The secant of pi over 2 minus an angle is equal to the cosecant of that angle. And also, cosecant of pi over 2 minus an angle is equal to the secant of an angle. The last section, I'm going to kind of go work vertically. The secant of the opposite of an angle, the sine of the opposite of an angle, or the sine of a negative angle, is equal to the negative sine of an angle. In other words, the sine of negative 30 degrees is the same as negative sine of 30 degrees. So it's the opposite of the sine of the positive. Similarly, cosecant of a negative angle is equal to negative cosecant of an angle. For cosine and secant, the cosine of a negative version of an angle is the same as the cosine of the positive version, or so the opposite angles have the same cosine. Same with secant. Secant of a negative angle is equal to the secant of the positive angle. So like the secant of negative 30 is the same as the secant of positive 30. Tangent. The tangent of a negative version of an angle is equal to the negative tangent of the positive version. So again, using 30 degrees, or pi over 6. The tangent of negative pi over 6 is the same as the negative tangent of pi over 6. Same deal with cotangent. Folks, you should have these all memorized by now. Just kidding. Folks, keep these in front of you as long as you can. In fact, I'm going to leave these on the screen off to the side here. Let me adjust what this window is going to look like so we can see both the identities and the work that we need to be focusing on. So let me shift this over a little bit. Oh, nuts. That's not what I was trying to do. We're going to make this work even if it's a little clunky. Okay, so we're just going to go with this for now. And on the next page, we're going to try some simplification. Yes, that's even hard to say. In general, when we're simplifying, that means to reduce the number of terms or reduce the amount of terms. And also, we're going to work hard to get rid of any fractions. We're going to start off with 1, the a term there, or the a example, where we have sine of x times the cosine squared of x minus sine of x. Yikes. Folks, when we're looking at problems like this, I want you to think about some algebra skills. So we have sine of x times cosine squared minus the sine. You'll notice we've got sine of x in both the first part and the second part. So we're going to use some algebra skills, and we're going to factor out a sine of x. When we factor out a sine of x from that first part of the statement, we have cosine squared of x. And then when we factor it out from minus sine of x, we're left with just minus 1. Now, cosine squared minus 1. Folks, pretty much any time you see some trig function like sine, cosine, tangent, cosecant, secant, and cotangent squared, you're going to use one of the Pythagorean identities. And since this is the first time we're encountering this, I'm going to do a little sidebar over here. So talking about a Pythagorean identity. Oops, sorry, I'm in shape mode still. And I'm just going to abbreviate it as a Pythag ID. Pythagorean identity relating to cosine squared is sine squared of x plus cosine squared of x equals 1. Now, I want to try to make it look something similar to cosine squared minus 1. So if we just subtract 1 from both sides, and also subtract sine squared from both sides, we would end up with, on the left side, cosine squared of x minus 1, and on the right side, we'd be left with negative sine squared of x. Before I go any further and plug this in, talking about trig identities, I talk about these and refer to these as puzzles. This is all about puzzles, and I'm giving you the puzzle pieces. The puzzle pieces that we're using here are these trig identities that I have off to the left side here that we're going to keep referring to. These trig identities are the puzzle pieces. Now, even if we know what puzzle piece we need to plug in, sometimes we have to kind of like rotate that puzzle piece around. That's kind of what's going on with this. That's like the same Pythagorean identity puzzle piece, just rotated around. So after we rotated that Pythagorean identity around, we got cosine squared minus 1 equals negative sine squared. In other words, we can replace that cosine squared minus 1 with negative sine squared. And so now we have sine of x times negative sine squared. That's the same as negative sine cubed of x. And that's as simplified as we're going to be able to get that statement. Now let's try another one. So in general, as I was saying a second ago, you're often going to use the Pythagorean identity. And then my other general strategy is get things in terms of sine and cosine as quickly as possible. So for example, on letter B, sine of t plus the cotangent of t times the cosine of t. I'm going to leave the sine of t alone, and cotangent of t, we're going to use one of your quotient identities and replace it with cosine of t over sine of t. And we're still multiplying that by cosine of t. That looks like the word cost. But what we just did there again, I probably should have the arrow going the other way. We just used a quotient identity. So again, cotangent is the same as cosine over sine. Now, we have on that, wrong page, there we go. We have a multiplication going on in that fractions, or that side on the left. So we have sine of t plus cosine of t over sine of t times cosine of t. I'm just going to set the cosine of t over 1. So that way we can do sine of t plus, when we multiply those two fractions together, we get cosine squared of t over sine of t. Now, we have one thing plus a fraction. So I'm going to make them both fractions. But in order to add fractions together, we got to have a common denominator. So to do that, what I'm going to do is I'm going to multiply both the numerator and denominator by the sine of t. So on that left one, we have sine of t times the sine of t. In the numerator, we have sine squared of t. Our denominator is just going to be sine of t. And then the other fraction, we didn't change the step around, but we got cosine squared of t over sine of t. Again, we just use this to find a common denominator. Common denom. But now we have two fractions with the same denominator. That means we can actually start adding them together. We got sine squared of t plus cosine squared of t, all that being divided by the sine of angle t. And that's just a simplify. We just combine two terms. Now, again, folks, that numerator, I'm hoping already starts to look familiar. Sine squared plus cosine squared is just 1. So this ends up being 1 over the sine of t. And again, that's one of the Pythagorean identities we just used. Pythag ID. Now, 1 over, I'm kind of running out of space here. 1 over sine, that's one of our reciprocal identities. That's just the cosecant of angle t. And again, that is a reciprocal identity.